here's what we're going to do today. We're taking a road trip to see if we can get some power for the e-bike. That's right, we're on our way down to Houston. It's early in the morning. We're going to Eon Lithium, if I can say it right. We're going to go down there, take a look at their facility they have, get you an inside look of what it takes to build these batteries, of a lot of the reasons why the cost is there, which this is going to be the biggest cost of the build. I really wanted to talk with them to see exactly what goes into doing this. So I've talked to Raymond, the owner of Eon Lithium. I really hope I'm saying that right. That's how it looks like it's spelled. So it's going to be a great day. The bike is all loaded up. I will say that dirt bikes are really, really, really easy to load up when you don't have any weight in them, when it's basically just an empty frame. So I apologize about the road noise. My little van is awesome, but it's not the quietest thing to take it down the road. If you can't hear me, I'll probably just edit this out and do it again later. So I could have just ordered the battery, but I want to show y'all what these companies are about. This is a smaller company who's hand making these batteries, and yeah, very interested in seeing that. If you're interested in seeing more of this kind of stuff, I love road trips. So y'all leave a comment down below if you are interested in seeing that. All right, we are here at Eon. Eon, is that how you say it?
Yes,
it's
Eon Lithium.
Eon Lithium with Raymond Yu, and he is the man behind the curtain, the puppeteer of all this battery stuff. And we're here to get some measurements for that bike. Y'all saw the intro, and I just started getting this wealth of knowledge from this man, and I had to share it. So we were talking about the different types of batteries. Now, I know a lot of people don't know. People who are watching this may be interested to hear about like the different, like I've seen 21P and this. I don't know what that means. Like, and you were starting to say that, and then I stopped him. I literally said, "Stop talking. It's too much good information." Okay. So when you see this, is it 21P or 20? What are we talking about there?
So in the world of batteries, there are two different terminology that people don't really understand. Mm-hmm. For example, the series counts, and that's what boosts your voltage from however many volts to where you want to get to. For example, each 21700 cells, mm-hmm. we call it 21700, is actually 2170. It refers to the dimension of the battery cell.
Okay.
So the diameter is 21 millimeters.
Oh, okay, okay.
The height is 70 millimeters.
So this is one that you would see in like a rechargeable flashlight by itself, kind of something along those lines. Like you take apart a rechargeable flashlight. I've seen stuff like this inside. And so the number you said is 21 by 70 millimeters.
Yes.
So it's the dimension.
It's actually the cylindrical
gotcha.
2 dimensions that people use, and then you add in pi, and there's your volume.
Yeah.
Now the thing is, maybe 3-4 years ago, 18650 was.
I know that, I've heard that. Yeah.
Was the biggest hit. Now is the 21700, and that's all we use now.
Okay, so that 18650 was just the size of the battery, like exactly. The physical dimensions.
Exactly.
I'll be dang. Okay.
It's not a model number, anything. It's just a dimension of the
gotcha.
cell. So we refer to different models on different company that makes them. Like this one is Samsung. Mm-hmm. This is the Samsung 50S.
Okay.
Which we use in 21S, 15P for electronical.
So that's what we're talking about. Yeah, those numbers.
So we're going back to that. 21S basically means that it's 21 in series. Uh-huh. So when you connect something in series, it actually adds to the voltage on the next one and the next one up.
So it makes it stronger, not capacity, but more. I'm like more beans, I guess you'd say.
I think it's more. It's a better interpretation of the cells being a hill.
Oh, okay.
So if you put a ball on a hill, it'll roll down, right?
Right.
So the taller the hill, the more energy that you have at the top. It's called potential energy.
Gotcha.
So when you have more cells in series,
you have more potential for energy.
More potential energy. So if you put this object on the table, drop it, there's the energy.
Yeah.
It's basically gravity.
Gotcha.
But in terms of electrical power, this is more like a potential energy in the electrical sense.
Perfect.
You're building up the voltage.
Uh-huh.
You use less amperage to achieve the same wattage.
Gotcha. Quick side note here. I'm editing this video, and I have to say, I hope everybody appreciates just how smart this man is. I mean, I understood a lot of what he was saying, and especially at the time, I really got it. There was so much information brought to me that day that I promise you that some of it was lost on me. I mean, and I feel like I'm not a dumb person, but like the amount of knowledge he had, and it was just endless. This interview is kind of short, like I'll say again in the video, but I just want to make sure if it's not making sense to some people, it's making sense to him. And the guy who's building your battery, you definitely want it to make sense. And I know a lot of guys out there understand this stuff, and they're laughing at me probably because I'm an idiot to them or whatever. But I just never mess with this stuff. And yeah, just real quick note as I'm editing this video that if I sound like an idiot in there, it's kind of because I am when it comes to this. And I just have to bow down to Raymond as he just knows this stuff and talks about it so nonchalantly. Him talking to Dawn, another gentleman, these guys know this stuff, and I have a lot to learn. And I'm hoping that through this process I can pass some of this on to y'all, and I hope y'all are following it maybe even better than I am. And I was there talking to the man.
So I think it's a simple modification. Voltage times amperage equals a watt.
Equals a watt. Yeah, I actually went over that with somebody the other day. They were explaining that to me.
Exactly. So where were we?
I don't know. He had a very important phone call to do. It was a busy man, so we're going to steal a few more minutes of his time. But we were talking about these batteries, about the size, the numbers. Like the 18650 is the dimensions. And this one's the
2170.
2170.
Yep.
And we were talking about when you had that little display there.
Yeah. Okay. So in this case, these are all just old batteries that we use for display. You can see all these positive side are connected to each other, negative side connected to each other, and these never should touch.
Right. Oh yeah, of course.
So there's the positive. Ink.
That's fine.
Yeah, that's fine. Okay. So there's the positive and there's a negative. And if you add another pile like this, connecting the negative to the first pack's positive.
Yep. Oh yeah, the bullets come off.
Yeah, it's too short for that,
So anyways, so you stack them up on top of each other.
If they connect like this in series, each cell here is 3.7 volt.
So this whole thing right here is 3.7 volts.
Yeah. So roughly about 4.2 when you fully charge it.
Okay.
Then you add another power on top, that makes it 8.2.
Gotcha. And so it just keeps going on top. And then if it was going out this way, like if you had more, you would just have
capacity.
You have like you said earlier, which I thought was it's like a tank, like a tank of water, or the more capacity.
Exactly.
Okay,
so
cool.
the more batteries there are, the deeper the tank.
Gotcha.
So these cells are 5 amp hours each. Now there is 10 of them in parallel.
Yeah.
This makes it 50 amp hours.
So it's 50 amp hours, and if you put another 10 next to it, we're going to use it as our display this way. It would still be 50 amp hours. It would just be right. It would be
100.
Well, 100 amp hours if you went this way. But if you stacked it on top, it would still be 50, and this be more
7.4
volts. Gotcha. Okay.
But it's
cool.
50 amp hours still.
Still 50 amp hours.
The watts still the same.
Gotcha.
Because you're just adding one on top, but the multiplication is still the same. So
I've seen this multiple times online. The 21P. What was the thing you said earlier?
So the batteries that we sell with Electro & Co, they're all 21S.
21 series. What does that mean? What does 21 series
So remember what we were talking about, the one stacking on top? That's 21 times.
Oh, okay. So I got you. So they take this, and it's whatever this is times 21.
21.
Okay.
Top. So say 3.7 volt each, you multiply by 21.
By 21. And so there's two numbers in that. There's a 21S.
And then the 15P.
15, which is the
capacity.
Okay, so it's 15 times 21 basically would be
the cell count.
The cell count.
Yeah.
Okay, I got you.
So 15. So some people, there's a common question,
Mhm.
right? I saw it on the Facebook group the other day. Someone asked a question. I'm just gonna put 4 of those 12-volt batteries in parallel, and then one more in series, make it 24-volt. It doesn't work like that.
No, I wouldn't think so.
It absolutely doesn't work like that. So if you see the ones that in parallel have way lower internal resistance, and the other one will have way higher, which means that it will heat up
because more is trying to go through that smaller pack. Yeah.
So the smaller pack will heat up. The big pack will go.
So they all need to be, all the packs, the 15P or whatever that would be. They all have to be 15. They all have to be. I got you.
So say you have 10 cells like this. The next one has to be 10 cells.
Yeah, and so that way, so this is something totally different. But like that's way, if one cell dies, the battery pack gets weak because now that cell below it is trying to force more through a smaller pack and overheating it.
Exactly.
Oh, cool.
And that's why when you select cells to build a battery pack, each cell needs to be almost identical.
We're within almost exact.
Yeah, within a millimeter difference.
Yeah.
So that's one of the things that people don't realize. If you do a DIY pack, this cell could be low, that cell could be high, and then they mash it all together.
Gotcha.
And you got a Frankenstein pack that doesn't really work well.
So when you're building these packs, they have a battery control module built in the pack, right?
So when we book these cells, right? So let's go back to this. We've got the Samsung. We've got the Lithium. These 2 cells have one thing in common, is that their consistency, each cell is really high.
Gotcha.
So if I was to say purchase 1,000 of these cells, let's say 4 or 5 of them no good.
Right.
That is preliminary. We vet them out, and then we select the ones that are good.
So like you said, the 3 point, what did you say?
So each one is 3.7 volts.
Okay, so if you're trying to find them that are like 3.69, 3.7, they all have to be perfectly 3.7?
No, that's not what I meant.
Oh.
So voltage does not tell you anything.
Okay.
Many people think that, okay, I can just put in the same voltage. It'll be good. It'll work, right?
Yeah.
We're talking about the internal resistance here.
Oh, so that's what you're checking for okay.
Yeah, the ohms.
The ohms
basically. Yeah, actually, in this case, milliohms. So usually the range is 15 to 19. I've seen some really good cells like Samsung. They rest around 10, 11. And all of them should be consistent.
Right.
And of course, you need to put them in together at the time of construction of the pack at the same voltage within three decimal points.
I got you. So that way that you don't have like a weak cell because it won't ever get charged up equally.
Yeah, and even if you have like different voltage but their internal resistance similar, all you need to do is make sure they're sitting at the same voltage and then measure again.
Gotcha.
So if they have the same internal resistance and you're putting them together in the same voltage, there should never be a case where it goes out of balance.
Gotcha. That's cool.
Yeah, and the one case I can think of is when they're undercharged. Let's say it's below 3 volts each cell. It starts getting wonky.
Gotcha.
Yeah, so I've seen cells that are like like Moly cell is really high internal, like high consistency, with the internal resistance. They also have really low resistance in each cell.
Yeah.
What that does is whenever you put together a pack, if it's grade A Moly cell, they'll all look the same no matter how you put it together.
Yeah.
You can put cell 1 to cell 99, it's still the same cell.
Right.
Yeah. So and a lot of people don't realize in the Moly cell market, there are a lot of, unfortunately, there's a lot of counterfeit. Grade B counterfeit.
Gotcha. Yeah.
So if you buy from a Chinese company, there's no way you're going to get grade A.
Right.
That's just the sad truth because Moly cell is not from China. Moly cell is from Taiwan.
Oh, okay.
And they have this whole trade thing, the fuel, they're not going to have grade A Moly cell, sadly. Right. So most of them is like actually grade B
or C.
Or even another cell that is impersonating the Moly cell.
Oh, I got you. It's just a regular cell that they call it a Moly.
Yeah, that's why they can sell it so low of a cost. And also they have a big factory.
That's interesting.
Putting them together. Yeah.
And you were showing me earlier the strips.
Yeah.
I thought it was really interesting.
So this is copper nickel fusion.
Yeah.
We put them in every single pack,
Yeah.
depending on how much current you need.
Right.
This one is slightly less. This is 0.5 millimeter thick. But depending on the current you need, we put in the copper in a thicker form.
Right.
So
and so what you were saying, and I'll edit in a zoomed in deal of
Sure,
this,
yeah.
but you have
you can
these.
keep this, by the way.
Oh, cool! You have these sections here that are
Laser
welded nickel to the copper.
Yeah.
And then because the copper moves the current much better and handles the heat better, you said.
Yes.
And then you can't weld the copper to the battery, so they laser weld these on here, so you can weld this nickel to the battery without overheating the individual cells.
That's right.
That's cool.
So, and for instance, this strip right here, you can see it's a 6-cell strip. This represents a 3 connection points each, because this side is the negative, this side is the positive.
So it would
they're connecting in a series.
Gotcha.
So the current that's being transferred from this point to this point, this point to this point, this point, is 3-point transfer.
Yeah.
So we calculate based on the volume of this
of the copper.
So of course you can't really see it right here, but it is 0.5 millimeter. So this right here multiplied by however much surface area there's a volume of how much current it can handle.
Okay.
So this is a grand example of what people don't really think of when they're building a battery pack. I've seen like people using nickel plated steel.
Yeah.
That is dangerous. So that's another point.
I like the look on your face. You're like, don't do that.
Yeah.
Do not do that.
So if you see this right here, there is a little peelable kind of barley paper ring that we put on every single cell before we put on it.
Right.
This is how they come.
Okay.
And then we put this over that. In case there is an overheat on the strip, it won't burn through the wrap, because under the wrap there's another plastic thing that only insulates the positive with the negative.
Gotcha.
So imagine this: if you're connecting the negative side to the positive side, and this burns through. Okay, I should flip it.
Yeah.
And this burns through. That means the negative out like the interior, the exterior of the negative cap will also touch the negative here.
Oh.
That means the positive that's connecting to here will connect to the negative side of it.
So that's how you get battery fires.
That's part of it. Yeah. That's part of it.
Yeah. Do not use those the nickel plated metal stuff, because you said that I guess that's bad because it'll overheat and that's what it will cause.
It'll melt through.
Melting through.
Yeah. Sometimes if it gets too hot, it can even burn the barley paper too. So stuff like this, the people don't really pay attention to it. But when you're building a battery pack, this is basically what you need to do.
Yeah, I've seen people online building battery packs, and they were just cutting up pieces of, I guess, nickel strips and then welding them.
Yeah.
And that looks like super sketchy. That's why I'm coming to y'all to be able to do this.
Well, we are doing motocross. So
what's something that holds up?
Yeah. Motocross, you've got the vibration to deal with. You've got the high discharge, instant burst of torque that you're just twisting it, giving it a go. What happens is you need that instant power.
Right.
You don't want the slow discharge. There's a lot of people building these packs. They're just putting on a tiny little scooter,
right?
Or like powering a fan.
It's not as detrimental to like, it doesn't hurt the power as much because you're not demanding as much.
Yeah, but you will see using copper will give you a lot more capacity.
Cool.
Because now you don't have heat loss.
Yeah. Oh, okay, I got you. Yeah. So you're not losing electrical power to thermal dissipation. It's actually going to the motor.
Exactly.
Yeah, I got you.
Otherwise, just traveling from one cell to the other, it's already burning heat. You got 21 series.
And that's the same thing. And I'm moving to the size of the battery. That's the same thing where you go with the 76 volt over like a 60 volt in something like this application, where you have more power on reserve, so the battery doesn't have to work as hard. So you have less heat transfer, and you can use smaller wires, right? Something like that. Okay.
Correct. Yeah. So the higher the voltage, the less amps you need.
You're right.
Yeah. So but the watts don't lie.
Yeah.
So say if you're doing a 20S, 10p, it's the same as 10S, 20p.
Okay.
The watt hour
Yeah.
is the same. The capacity is the same. However, 10S 20p will require a thicker wire to do the same
Because
wattage.
it's pulling harder on that battery.
Exactly, because you know, volts times amps equals to watts.
Yeah.
You know, amp hours times volts equals to watt hour. So it's the same thing. The math is the same as multiplication. So one side go up, the other side go down.
So if you have the same amp hour, right,
Mhm.
but this battery is smaller, you know, amp hour versus this one, will they last the same amount of time if they, you know, or will the one that gets hotter,
It will go out faster.
It go out faster because it's losing power to thermal radiation. You got
dissipation.
Dissipation, yeah.
Thermal dissipation. So if you got, let's say like our example, you know, 10S 20p. If you're still using copper, that will be minimal.
Okay.
But if you're still using the same, you know, say nickel or even steel.
Yeah. I just love your face when you say steel. You're like, y'all guys do not do that. Don't do that.
Because that stuff is the cheapest, and it's for some reason everybody buys those.
Yeah.
And it just doesn't make sense.
Fair enough.
I mean, you're doing a battery that which could, you know. Okay, so talking about this, it also there's a difference between the chemistry. So like lipo cells, those are pouch cells. They have a lot less life cycle than people realize.
Yeah.
These cells right here, they can do 1,000 cycles, 500, 1,000, depending on how you use them.
Yeah.
Lipo is 300, 500.
We're back for this man. I'm telling you, his phone's just blowing up. It was just a good thing. It's a good thing. It's a reason.
It's not that bad. It's not that bad. I try to answer every phone call.
I'm going to help. Before we go any further, I just want to say how much I appreciate it, and hopefully people who deal with you appreciate it. Like being able to call and talk. I know you can't do this forever and talk to somebody every time as your business grows and y'all get busier. We just talked to what's his name from
Austin.
Austin was on the phone. Austin's calling him for stuff. You know, those kind of things from Electro & Co. I mean, this guy's busy, so you're not going to get his attention forever as his business gets bigger and bigger. But for right now, I appreciate it. So
shoot me an email.
Shoot me an
email. Yeah,
email as always.
So we were talking about steel.
Yeah.
So like this kind of stuff sells so well on. You know, you can get your hands on nickel-plated steel. You can get your hands on steel strips on Alibaba, AliExpress, whatever you want to get it from. It's gonna be always cheapest. You know, you've got sea shipment. Two months later shows up for $5. You know, you can't use this stuff anywhere unless you're doing, you know, a computer build where you know you've got a giant battery bank and you know just want a backup power.
And it's like a slow drain.
I mean the backup power. You know, like a UPS kind of thing.
You know what that reminds me of, and this may not make sense. I don't know how much you have to, but my listeners will know. I get a lot of kits and stuff that have, well, the bolts say 8.8 on them, and they think that means grade 8. And because here in America we use the grade 8, right? They think it's grade 8, which is not. 8.8. Those bolts that come from bikes from China and that kind of stuff, or parts from there, it's actually our grade 5.
Yeah, 8 millimeters, right?
No, 8.8 is its shear strength. It's just
okay.
So here we're getting into the weeds, and I'm sorry about people are probably already logging off. But anyways, the people. So that bolt, that 8.8 bolt, will shear like a grade 5 here in America. So it's called 8.8 grade, and we have grade 5. And then the stuff you want, if you're buying bolts and stuff and kits that come from like Japan or China or any of the places that use the metric system, it's grade 10.9 or 10.9 grade, and that's all the same as American. Actually, it's a little stronger than American grade 8 bolts. So it's kind of the same thing where you know you can use those bolts for situations that don't have shear force to them. If it's holding on a bracket, holding on so it's fine.
Like a license plate or something.
Yeah, exactly. But when you're using it like to hold on foot pegs or something that you're gonna, you don't want to do that. And the same thing with the metal strips. You have like a small backup battery. You have like something like you said in computers and that kind of stuff, those work. But in these situations where you have a lot of demand on the battery and a lot of shock loads and that kind of stuff, then you definitely want a higher grade material like what you have.
Exactly. So, for instance, for motocross,
Mm-hmm.
I mean the minimal I've seen 150 amps.
Yeah.
That's the entry level stuff.
Yeah.
You know, we're talking about 300-400 amps.
Yeah. I think the controller I have
amps.
is 4 something. I think is what it goes up to.
Yeah, 450 I think.
Yeah, I think
Something
so.
like that.
Yeah.
Yeah. 350 minimum, 450. Yeah, that's average.
Yeah, exactly.
You know, we're talking about, you know, some people do even 1,000 amps.
Wow. Yeah.
It's nuts. I mean, you've got people who want to raise and
Yeah.
put a lot of money into this, and they need the good stuff, and you know they don't realize, okay, I can just ship out and get it from China, and you know, like we've got a lot of people saying, hey, you know, your stuff is too expensive. I'm like, no, it's not.
No, you get what you pay for.
No, it's not. You know, I mean, you look at the stuff that we put in, the attention into each weld.
Yeah.
You know, nickel is already kind of at the bare minimum. You
Right.
know, if you're doing nickel, yeah, it's gonna heat, but it's not gonna be that bad.
Right.
But if you don't put copper on, you're
Yeah.
gonna lose a lot of range, lose a lot of voltage on sag, because when you're twisting it, all that voltage goes through the nickel strip. It's gonna lose that power when you're going. So you know, this kind of stuff we just kind of give it as a general information, but nobody listens to it sometimes. So
they're not going to listen here, I guarantee you.
Yeah.
But no, I really appreciate it. That's pretty interesting. So I guess we'll go out there. We'll see what we can do about the batteries for this bike. And you were saying the difference in those cells right there.
Yeah. So these are the two cells that we use most commonly now. The Lithium is a lot cheaper than the Samsung, of course, and it's 4,000 milliamp hours. We get the grade A stuff. The grade A stuff is roughly about AC. So when we're talking about C, is basically the power in comparison to the capacity.
Okay.
So 8C basically means that it's 8 times the capacity of the discharge. So this one is 4,000 milliamp hour. Therefore, it can discharge at 32 amps.
Okay.
Per cell.
Per cell. Okay.
So if we do like a 10P,
yeah,
that's 320 amps.
And then you would stack them on top, so you have a whole bunch of 320 amps.
Exactly.
I got you. So what's the difference with the Samsung?
The Samsung is a 10C battery, and it also has a higher capacity.
Okay, has.
It's 5,000 milliamp hours, so it equals to 5 amp hours.
Yeah.
10C is 50 amps each.
Gotcha.
So at the same configuration is not only more capacity, but more discharge rate.
Okay, so if you can so right now he's already convinced me he hasn't realized it that I want the Samsung battery cells. It sounds like.
Well, the Samsung is roughly about 2 times more expensive.
Price wise, yeah.
And that's why not everybody wants the Samsung, because you know you want a little bit more power. The comparison, you know, there's a percentage of improvement per
return
cost.
on gain, return on investment.
Yeah, exactly. So some people just say, hey, might as well throw more, you know, Lithium cells into it instead of 2 times the cost. You know, we do 1.5 times more cells. Yeah. You know, and then you still achieve the same goal and stuff like this. You know, if you got the space, you got the way for it, you know, might as well.
Yeah, sounds good. All right, so we'll do this, and then I'll show around some of the little bikes we got going on here, and then I'll get out of your hair because you're a super busy man.
No, I'm not that busy.
All right, what a trip. And I've got some thoughts and some thinking to do. And those thoughts and thinking are a lot about this battery situation. This has been a heck of a week. The shop's a mess. Been rushing to get this done, so now, yeah, got to come up with something. I had a great visit with Raymond, and what you're going to see on video is maybe half of all the knowledge he had. The dude is a wealth of knowledge, and what I've learned is open up a lot of questions. What's being called into question is our budget. Issue we have is going to be maybe the way I went about it. Maybe I was wrong. Sometimes it can be hard to admit when you're wrong, and I think me going about this custom battery build, I may be better off just going with a pre-built battery. I can tell you why. Obviously, on this build, budget is important. I am trying to build the best bike I can for under a certain budget. Building a full custom battery with a custom case, with all that kind of stuff, is going to push me outside my budget. And yes, that may be the best route for the most power, the biggest thing, but I got to be true to what I say. And I genuinely am trying to do this for less than the price of a Suron. So I know this is possible. I know it can be done. And I think the sacrifices on a little bit of battery size is gonna help with a couple things. You'll see the battery when it comes in, and I got plans for that. But this week has been a slog to get this bike to this point, and I have to go to work. Anybody who knows me knows I work out of town, and I'm going to be out of town for a couple of weeks. During that time, it's going to allow him to get the battery together, get it shipped to me. And so the next time you see this bike, I will be putting a battery in it, and yeah, I'm going to be riding this thing. So things have changed, but they really haven't. The budget's going to stay the same. I don't think I'm going to wind up getting 75 amp hours is what I was really hoping for. The frame is just not conducive to that, but I don't know if I need that. So I make mistakes sometimes on this channel, and I will definitely tell you what they are. And I'm not saying this is a mistake. I don't know. And I'm trying to help people put together a plan for a build for themselves. And I think buying the pre-built battery, buying that kind of stuff is going to be what a lot of you are going to do. A lot of guys are going to want to know what happens when I just straight up buy a battery. And so that's what I'm going to do. All else fails, we're going to budget the whole way. So I can't thank Raymond enough for being honest with me, for being upfront, for letting me in to see his world and pick his brain. I know that video you saw was somewhat short of us talking. There was probably 2 hours of us talking. Austin from Electro & Co. was on a FaceTime, and we talked too. The guy is super busy, and but took his time out to talk to some random guy who he doesn't know, and I really appreciate that. So, yeah, we're back from Houston, and the trip went pretty well.